Alright, we now know that arithmetic mean is greater than or equal to geometric mean. Let's put it to use. We are going to solve a few questions, and the only thing you need to know is that AM is greater than or equal to GM. That's the only theory you need. Starting with this one, we have sum of A, B and C given to us as 18, sum is constant, and we want to find maximum value of this product. We want to find maximum value of ABC. So sum and product, AM and GM. For AM, I need A plus B plus C. For AM, I need A plus B plus C upon 3. And for GM, I need ABC whole raised to power 1 upon 3. This is given to me. This I am required to find. So AM is what? A plus B plus C, that is 18. 18 upon 3 is 6, which will be greater than or equal to ABC raised to 1 by 3. On cubing both the sides, why am I cubing? To remove this 1 by 3, to get rid of this 1 by 3. On cubing both the sides, I will get 216 in the left hand side and ABC on the right hand side. So maximum value of ABC is 216. Now let me rephrase this question. Sum is still 18 and ABC are distinct positive real numbers. Then ABC would be. So in the previous question I had ABC less than or equal to 216 when ABC were positive real numbers. The word distinct is not used here. ABC can be equal as well. Now we know that AM is greater than or equal to GM. So minimum value of AM is GM. At least AM will be equal to GM. And for minimum value of AM, we want an equality sign here that will come when all the terms A, B and C are equal. Now here when A, B and C are given as distinct, that means they cannot be equal. That means AM cannot be equal to GM. So ABC cannot be equal to 216. Right? This equality sign cannot come here. ABC will always be less than 216 as the word distinct is used here. Okay. Next question. Well, an incremental change over the previous one. A plus B plus C, the sum is same as before, but in place of ABC, now I have A minus 1 into B plus 4 into C. That makes it a little tougher. These three quantities are in product, so I'll want them in GM, right? I want this product in the right hand side. So in the left hand side as well, I want sum of these three quantities. For GM, I have A minus 1 into B plus 4 into C whole raised to 1 by 3 as these are three quantities. So in the left hand side as well, I will need A minus 1 plus B plus 4 plus C, sum of these three quantities upon 3. And this, by the way, I can easily get. This is nothing but A plus B plus C minus 1 plus 4, that is plus 3. This numerator is A plus B plus C plus 3. A plus B plus C is 18, 18 plus 3 is 21, 21 upon 3 is 7. And when I will cube both the sides, I will get 7 cube in the left hand side, that is 343. And in the right hand side, I will get A minus 1 into B plus 4 into C. So maximum value of this product is 343. Next question. Now this is simple. I know that this product will come in place of GM. This product in some form will come in place of GM, and this sum in some form will come in place of AM. So I will straight away write this product in place of GM, A square into B into C cube whole raised to power. Now what power should I write? Are these three quantities? Are these A square into B into C cube? Or am I considering these as 6 quantities? Is it A into B into C into C into C? Now which way I am going will totally depend on what I have for the left hand side. So do I have A square plus B square plus C cube given to me, or do I have A plus B plus C plus C plus C given to me. Yes, the second information is given to me. I have 2A plus B plus 3C as 18. So in the left hand side I will have AM, which is A plus B plus C plus C plus C upon 6, which will be greater than or equal to GM, that is product of these 6 quantities, these 6 terms raised to power 1 upon 6. This sum is 18, right? 18 upon 6 is 3. I'll take whole power 6 on both the sides because I want to get rid of this 1 by 6. So 3 raised to power 6 will be greater than or equal to A square into B into C cube. So maximum value of this product is 3 to the power 6 or 729. Moving on to the next question. What? Mr. Anshul, why have you taken all the questions so similar? This confuses me. Well, that's the point. AM is greater than or equal to GM. Now this sum in some form will come in place of AM and this product in some form will come in place of GM. In the previous question, I had 2A plus B plus 3C. I had 2A in sum and I had A square in the product. So I wrote A square as A into A because I had A plus A given to me. Here also I can write A square as A into A, but I will need 2 A's in the left. I will need 2 A's for the sum. So can I split this A into 2A? Yes, I can split it into 2 parts. I can write this A as A by 2 plus A by 2. And this B will come as it is because I have only one B in the right hand side for GM. And then C will come as C by 3 plus C by 3 plus C by 3. I am splitting C into 3 parts because I have product of C 3 times. I have C multiplied by itself 3 times. I have C cube in the right. And AM is what? Sum of these 6 quantities upon 6, which will be greater than or equal to product of these 6. A by 2 into A by 2 into B into C by 3 into C by 3 into C by 3 whole raised to 1 by 6, as these are 6 terms. Now this sum is 18, right? A plus B plus C is 18. 18 upon 6 is 3. And I'll take whole power 6 both the sides. So in the left hand side I'll get 3 to the power 6, which will be greater than or equal to A square upon 2 into 2, that is 4, into B into C cube upon 3 into 3 into 3, that is 3 cube. So I'll take this 4 and 3 cube in the left hand side, I'll transpose them and I'll get 3 to the power 9 into 4 is greater than or equal to A square B C cube. So maximum value of A square into B into C cube is 3 to the power 9 into 4, which I won't be calculating, as you should be focusing on the concept rather than this value. So these were a few questions in which sum was given to us as constant and maximum value of product was to be found out. AM was fixed and GM's maximum value was to be calculated. Now what if GM is given to us as constant? Well, in that case we can find minimum value of AM, and we will discuss this scenario in the next video. I hope you liked this one. Thank you.